Ever been, really wrestling with a long piece of writing? Maybe halfway through you felt like your original plan just wasn't cutting it anymore.
Oh, definitely. It happens all the time.
New ideas pop up, or you realize you need to dig deeper into one specific area, and suddenly that perfect outline feels more like a cage, really.
Yeah, a roadblock, exactly. That traditional linear way of planning, it often just feels, well, inadequate when things get dynamic. Writing, researching the process itself changes the plan.
Which is why we're diving deep today. We've got this really fascinating research paper. It's called Beyond Outlining, Heterogeneous Recursive Planning for Adaptive Long-Form Writing with Language Models.
Right, by Ruibin, Xiong, and colleagues. Really interesting work.
Yeah. So our mission here is to unpack what looks like a genuinely innovative approach for AI writing, something that promises better quality, but also much more adaptability, moving beyond static blueprints.
Precisely. And it tackles a core problem in how AI generates long stuff right now. How do you get these systems to write coherent, quality pieces without locking them into a plan that stops them adapting or reasoning more deeply as they go?
Okay, so this new thing is HRP, Heterogeneous Recursive Planning.
That's the one. And it offers a really compelling, and I think importantly, a more sort of academically sound solution than the usual plan right method you see a lot.
Okay, let's talk about that plan right method first then. What's the fundamental issue there, especially from an academic angle? Why isn't it good enough?
Well, the paper really critiques its rigidity. That's the core academic point. Lots of current AI writing agents, they work by building this super detailed outline first, right? A whole hierarchy of what they're going to write before any actual words are generated.
Like mapping out the entire journey before taking the first step.
Exactly. The paper mentions a few examples like Bai et al.'s work using plans for length control, Agents Room for planning story narratives, Storm for Wikipedia-style articles based on outlines.
Co-Storm too, right, for reports.
Right, CoStorm optimizing those report outlines. But the big limitation, academically speaking, is that lack of adaptability.
Okay.
Once that plan is set, the system really struggles to, weave in new info that comes up later or to shift its thinking if the writing process reveals something unexpected.
Like that mystery novelist example, finding a new clue mid-story throws the whole original plan out.
Precisely. The AI gets stuck with its initial hypothesis even when the evidence, the stuff it's generating or finding, suggests it needs to change course.
So it can't easily revise its own thinking. Okay, so how does HRP, Heterogeneous Recursive Planning, get around this? What's the innovation here?
HRP basically merges outlining and writing into one more fluid process. The paper calls it human-like adaptive writing.
Human-like, how so?
Through what they call recursive task decomposition and dynamic integration. The really neat academic innovation is drawing inspiration from hierarchical task network planning, HTN.
HTN. Okay, what's that?
It's a known AI planning thing where you take a big high-level goal and you recursively break it down. You decompose it into smaller and smaller subtasks until you get to things the system can actually do.
Ah, okay, so instead of one big fixed plan up front.
Right. It's more like a dynamic process of breaking the writing task itself into smaller linked goals as you go.
And the academic twist is how it categorizes these smaller goals.
Exactly. That's a key innovation. It breaks them down based on what they see as fundamental cognitive tasks in writing: retrieval, reasoning, and composition.
Okay, let's dig into those three. From a more academic view, how do they define retrieval in HRP?
So retrieval is about getting information, accessing external sources, databases, its own memory, whatever. Functionally, it's about boosting the agent's memory with context-independent info, like looking things up dynamically during the writing.
Makes sense. You always need to pull in facts. What about reasoning?
Reasoning is the thinking part. Planning, manipulating the information logically, structuring things, resolving conflicts, deciding on the flow, the arguments. Academically, think of it as transforming memory based on logic and planning rules, not just getting facts, but actively processing and organizing them.
Got it. The critical thinking bit, ensuring it all hangs together logically. And composition.
Composition is the actual writing, generating the text, revising it, transforming the results of retrieval and reasoning into language. Computationally, it's changing the workspace, the document, and that change also updates the agent's memory.
Retrieval, reasoning, composition. Okay, so HRP says writing boils down to these three. Now tell me more about the recursive and the heterogeneous parts. Why are they innovative?
Okay, recursive means it keeps breaking the tasks down. A writing goal gets decomposed into these subtasks: retrieval, reasoning, composition, and then those subtasks might get broken down further and so on until you hit primitive tasks. things the AI can just execute directly.
Like write this paragraph or search for this term.
Exactly. And the heterogeneous part, this is really core to the innovation, means the system knows what type of task it's dealing with during the breakdown. It doesn't treat all subtasks the same.
How does that help?
Well, the strategy for breaking down a retrieval task, like find info on X, might be very different from breaking down a reasoning task, structure the argument for section Y, or a composition task, write the intro. It allows for different approaches based on the task's nature.
So it's not just that it breaks it down, but how it breaks it down, tailored to the task type.
Precisely. They even have hypothesis 1, type specification and decomposition, basically saying every subtask can be clearly labeled as one of these 3 types.
And why is that labeling important, academically?
2 big reasons. 1, it opens the door to using specialized agents, maybe different AI models or software bits optimized for each task type, like a great searcher for retrieval, a logical planner for reasoning.
And a fluent writer for composition. Makes sense.
Exactly. And 2, it lets them use different logic for breaking down each type of task. Different decomposition heuristics, they call them.
Right, using the right tool or the right thinking process for the right job. What about those heuristic decomposition constraints mentioned? What do they do?
They're like guardrails, ensuring the whole process stays logical and leads to good writing. The paper mentions 2 main ones. First, after you do retrieval tasks, you always stick in a reasoning task.
Why?
To make sure the AI actually processes the information it just gathered, integrates it, before moving on. Makes sense, right?
Yeah, digest the info before acting on it. And the second constraint.
Second, composition tasks always have to end up with an actual writing subtask, so all the planning eventually leads to putting words on the page.
Okay, so constraints to keep it coherent and productive. Now, this sounds complex, dynamically breaking things down, different task types. How does HRP actually manage all this? How does it decide what to do next?
Good question. They use something called a state-based hierarchical task scheduling algorithm. Basically, it keeps track of all the tasks and their dependencies using a graph, a directed assignment graph, or DAG.
Like a dependency map, task B can't start until task A is done.
Exactly like that. And each task has a state: active, suspended, maybe done. The key thing is a task only becomes active, ready to execute, when all the tasks it depends on are finished.
Okay.
And if a task isn't primitive, if it needs further breakdown, the algorithm handles that decomposition then. It's this constant interleaving of planning, breaking tasks down, and execution doing the primitive tasks.
So it doesn't need the whole plan up front. It just figures out the next doable step, does it, and then plans the next bit based on the result.
That's the core idea. It makes the whole process adaptive. The system plans and writes dynamically, reacting to what it's just done.
That sounds much more like how a human might actually work on a complex piece. Theoretically cool, but does it work? What's the proof?
They tested it pretty rigorously, 2 very different kinds of long-form writing tasks to show it's not just a one-trick pony. First was narrative generation, fiction writing.
Okay.
Using the Tell Me a Story dataset. They compared HRP against Agents Room, which is a known method for AI story writing. They used fancy LLM-based metrics to judge plot, creativity, characters, setting, language, the whole package.
And the results?
HRP came out significantly ahead on all the metrics, and this wasn't just a fluke with one AI model. It worked better using both GPT-4o and Claude 3.5 Sonnet.
Wow, across the board.
Yeah, which suggests the HRP framework itself is making the difference, not just the underlying language model. And interestingly, the advantage HRP had seemed to get bigger for longer, more complex stories.
That's compelling for creative stuff. What was the second task?
The second one was report generation, more technical, info-heavy writing. They used the WildSeed dataset for this.
And who did they compare against there?
Against Storm and CoStorm, which are sort of these standard baselines for generating reports using retrieved information.
And? Same story.
Pretty much. HRP again showed statistically significant better performance. Reports were judged better on relevance, breadth of information covered, depth of analysis, even novelty of insights.
So better stories, better reports. Seems robust. What about those ablation studies they mentioned? What were they trying to prove there?
Ablation studies are where you deliberately break your own system to see what happens. Here, they tested 2 things. What if HRP wasn't recursive? And what if it didn't care about the task types, retrieval, reasoning, composition?
And what they'd happen?
Performance dropped significantly in both cases, which provides really strong evidence that both the recursive breakdown and paying attention to the task types are crucial for making HRP work so well. They're not just fancy extras, they're essential parts of the innovation.
Okay, that really nails down the importance of those core ideas. So let's try and summarize the big academic innovations here. What are the key breakthroughs this research represents?
I'd say there are a few big ones. First, just the conceptual leap from that rigid plan first approach to this dynamic interleaved planning and execution. That's a fundamental shift.
Right, changing the whole workflow.
Second, formally defining and using those three cognitive task types, retrieval, reasoning, composition, as the building blocks. It gives a more granular, cognitively plausible way to think about the writing process for an AI.
That categorization feels really central.
It is. And third, building on that is the recursive decomposition that respects those types, breaking tasks down differently based on whether they're about finding info, thinking, or writing. That allows for more sophisticated strategies.
And specialized tools, potentially?
Exactly. And finally, the task scheduling algorithm itself is innovative, managing this complex dynamic process effectively and adaptively. Put it all together, and you get an AI that can handle the messiness of long form writing much more like a person might, adapting as it goes.
And potentially leading to more efficient and higher quality writing by using specialized AI components for each task type. That's a really interesting future direction. Did the paper mention any limitations or next steps?
Yeah, they did. They acknowledged that all this recursive decomposition can be computationally heavier than simpler methods. So future work could look into making the task breakdown and scheduling more efficient.
Makes sense. Anything else?
They also pointed to integrating human feedback more tightly into the process. Having a human in the loop at different stages of HRP could really boost the adaptability, the creativity, the overall quality even further. That's a big area for future research.
Okay, so wrapping up our deep dive here, focusing on the academic side. HRP, heterogeneous recursive planning, seems like a really significant step forward for AI writing. It gets past the rigid outline problem by using this dynamic interleaved approach.
An approach grounded in these distinct cognitive task types.
Managed by that clever scheduling algorithm, it leads to better adaptability, better quality across different types of writing. The big innovations really are that recursive, type-aware decomposition and the dynamic scheduling.
Exactly. It's a move towards AI writing systems that are, well, more sophisticated, maybe more cognitively plausible, and definitely more effective for complex tasks.
And for you listening, if you're tracking AI research, hopefully this gave you a solid grasp of why this HRP approach is genuinely novel and important from an academic standpoint. It's one of those aha moments, seeing how they tackled this complex problem.
And it makes you think, doesn't it? Could this idea of breaking down complex work based on its fundamental cognitive demands, like information gathering versus planning versus doing apply elsewhere, not just AI writing, but maybe your own research projects, your own problem solving?
Could thinking about the type of task help you be more adaptive and effective?
It's a fascinating thought.
Definitely something to mull over. If this has piqued your interest, absolutely check out the paper itself or look into related AI planning and cognitive science ideas. Lots more to explore there.